Hello friends, welcome to my channel Math Essential. Myself Satyajit Mahapatra, a research scholar at IIT Kharagpur. So today's video is about the application of trigonometry to measure the height of a mountain. So can we measure the height of a mountain using a little bit knowledge of trigonometry and some homemade setup? So in old days people used to look at the tip of a mountain through a see-through pipe and they could easily calculate the height of the mountain. So in today's video, we will have a small demonstration and let us see how can we measure the height of a mountain. So let us first go into the mathematics of it. So this is the mountain whose height is to be measured and our position is at a horizontal distance of capital L here and our vertical position of our eye level is at a height of small h. So the angle of inclination or elevation of the mountain top is theta here. So we are looking through a pipe here to the mountain tip. So let us name this triangle as ABC. A little bit of trigonometry like using a tangent function tan of theta is nothing but the perpendicular by base. So in this case the perpendicular is given by AB and the base is BC, and we can easily verify that this, so AB is equal to capital H minus small h and the value of BC is L, height of the mountain h is equal to, so small h plus L into tan of theta. So to measure the height of the mountain capital H, so we need the vertical position of the eye level small h and the horizontal distance from the mountain capital L and the angle of elevation theta here. So how can we find out the value of theta? So whereas we can use suitable measuring devices to obtain the value of this small h and L, so the theta needs to be obtained from a suitable device which is known as a clinometer. So this is a device which is basically used to measure the angle of elevation and angle of depression. So it consists of a see-through pipe, and to measure the angle, a angle measuring device is attached with this. So we will be using a homemade setup here. So with this pipe, we will align the diameter of the protractor and we will hang a weight through this. So you know that due to gravity, this weight will be always in the downward direction. So when this is at the horizontal position, so the angle measured will be our reference angle, which will be known as 0 degree. So in actual protractor you will see that this will be 90 degree. So that we will take as the reference. So once we want to measure the angle of elevation of the mountain, so we will align this pipe with the line of sight and we will see through this pipe. So your weight will again hang in the downward direction, and this was 0 degree. So this angle will give you the angle of elevation theta. So this will be the angle of elevation theta. So this is also theta, they are same. So using this homemade clinometer, we will be able to measure the angle of elevation. So because it is not easy to verify the height of a mountain, so in our demonstration, we will locate a certain point in the wall, you will see in the next video. So after the demonstration, we will be doing the necessary calculations and further we will verify the results with the actual value of the mountain of that point. So this is a clinometer that will be used to measure the elevation of the mountain, and this is made up of a pipe and a protractor and a hanging weight. Let us now go to the demonstration. So when the pipe is at the horizontal position, you can see that this is at the 90 degree, which is our reference angle, that is 0 degree. Now when we see the tip of the mountain at some elevation, now you can see that the angle has changed. Now we can easily measure the angle. This is the clinometer and the arrow pointing the hypothetical mountain tip, the red dot whose height is to be measured. The vertical height and the horizontal distances from the eye position are marked with the chalk here. So when the pipe is at the horizontal position, the protractor reading is 90 degree, which is the reference 0 degree angle. Now we will try to look the red dot through this pipe and will measure the angle. The red dot now can be seen at the middle of the pipe. So now we will measure the angle of elevation. So the reading is around at 119 degree and the angle of elevation is 29 degree. Next we measure the vertical position of the eye level. This is at 102.5 centimeter. Next we measure the horizontal distance of the eye position. This is around at 181 centimeter. So now friends, as you have got the required information to calculate the height of the red dot, so h was found out to be 102.5 centimeter and the horizontal distance of the eye position was found out to be 181 centimeter and the angle of elevation was measured to be 29 degree. So using the above formula you can easily calculate the value of the height of the mountain tip. So 102.5 plus 181 into 10 of 29 degree. So this value is calculated to be 202.82 centimeter. So let us now verify this result with the actual measurements. So the actual measurement value can be seen here in this step to be around that 203 mark, that is 203 centimeter around. If you like my videos, like this video and subscribe my channel. Thank you.